Physical and chemical changes on page 143. On the right hand side of 143, there's the what you'll learn. Today, scholars are going to identify physical and chemical changes, and you will exemplify how physical and chemical changes can affect the world that you live. We're going to try and be able to identify what is the defining property of a physical change and a chemical change, and then be able to distinguish those given a certain scenario. You're going to have to do this in your chapter review and test to say, well, is this a physical change or a chemical change? So we'll be able to see where that is playing out in real life. One example of a physical change comes from this video, which is from last year, January 13th, of the Bradley Center being completely destroyed. As you know, if you've been downtown in the last year, the demolition process is finally done. Look at that. Huge, massive explosion, takes down the roof, completely destroys the Bradley Center. However, this is considered a physical change, not a chemical change, because guess what? Even though there was this massive explosion, all the different parts of this building are still those same materials. For example, the metal roof that was just blown up and imploded is still pieces of metal. They're just shattered and scattered all over the place on the inside. The brick and the concrete that makes up all the different parts of the foundation of the building are still that brick and concrete, so it's the same material. A chemical change would be where there's a distinct change in that substance and it changes to a completely new property. The explosives themselves would have probably caused some type of chemical change because they're blowing up with that reactivity because that flame is introduced to them. That would be an example of a chemical change, but here you're observing a physical change because those materials are still exactly the same. Let's jump into, again, learning a little bit more about the difference between physical and chemical. On page 143, physical change. The crowd gathers at a safe distance and the cameras from a news media are rolling. A sense of excitement, fear, and anticipation fills the air. The demolition experts are making their final inspections. Then, in just a few seconds, the old stadium becomes a pile of rubble. The appearance of this stadium changed. What is a physical change? Most matter can undergo physical change. A physical change is any change in size, shape, form, or state where the identity of the matter stays the same. Only the physical properties change. The stadium, in Figure 12 and in the video we just watched at the Bradley Center, underwent a physical change from its original form to a pile of steel and concrete. The materials are the same, they just look different. A reading check says, what is a physical change? And I would have in class pulled out a piece of paper and asked you to crumple it up and then either throw it at me or launch it at the garbage can to say, hey, this is still a piece of paper even though it's crumpled up. That's an example of a physical change. It's again changing its size, shape, form, or state where the matter stays the same. It's still the same material. Flip the page. Examples of physical change. How can you recognize a physical change? Just look to see whether or not the matter has changed size, shape, form, or state. If you cut a watermelon into chunks, the watermelon has changed size and shape, but guess what? It's still watermelon. That's a physical change. If you pop up one of those chunks into your mouth and bite it, you change the watermelon's size and shape again. Not until you start digesting it does it become a chemical change. Change of state. Matter can undergo a physical change in another way too. It can change from one state to another. Suppose it's a hot day, you and your friends decide to make snow cones. The snow cone is a mixture of water, sugar, food coloring, and flavoring. The water in the snow cone is solid, but in the hot sunshine it begins to warm. When the temperature of the water reaches its melting point, the solid water begins to melt. The chemical composition of water, 2 hydrogens and 1 oxygen, does not change. However, its form changes. This is an example of a physical change. The solid water becomes a liquid and drips into the sidewalk. As the drops of liquid sit in the sunshine, the water changes its state again, evaporating to become a gas. Water also changes from solid to liquid by melting. Other examples of change of state are shown in Figure 13. So a change of state, water's a really good example because water can go from a liquid to a gas in the form of evaporation. It's still water vapor. It's still H2O. Water can go from a liquid to a solid by freezing. It's still water. It can go from a solid to a liquid by melting. It's still water. If it's still the same material, just because it's changed its state doesn't mean that it's changed physically or chemically. It's a physical change if it's changing its state overall. Here's a couple examples that align with what's on the bottom of page 144. Here you've got metal. This is molten metal. It's actually metal that's been heated so much that it's gotten to the melting point, and now it has turned into a liquid, as you can see it being poured out and formed into these casts. Is how you can make different things out of metal because it's malleable. You can get it to a point where it's melted, and then it can be poured into something that has a distinct shape, and the metal will take the shape of whatever that is, and then that's how you can create different types of parts. Here's an example of water going from what would be the vapor state into a liquid state. When it's near a surface that's cooled down, or in the clouds when it cools down, it turns back into a liquid. That's condensation. Melting, another example. Your ice cream cone gets too hot, don't eat it fast enough. Sweating is a really good example, or perspiration, because when you sweat, that water is actually evaporating into water vapor. That's what causes your body to be cooled down. But it's still water that is being excreted and then turned into water vapor. It's still the same material when you have that change of state. Now the difference here is chemical changes. Chemical changes on page 145. Unprotected cars driven on salt roads and steel structures like the one shown in figure 14 can begin to rust after only a few winters. A shiny copper penny becomes dull and dark. An apple left out too long begins to turn brown. What all these things have in common? Each of these changes is a chemical change. A chemical change occurs when one type of matter changes into a different type of matter with different properties. The definition here: one material changes into a different material with different properties or characteristics. Examples of chemical change. Chemical changes are going on around you and inside you every single day. Plants use photosynthesis to produce food, the product of chemical changes. When you eat fruits or vegetables produced by photosynthesis, these products must be chemically changed again so that the cells in your body can use them as food. There are many chemical changes occurring outside of your body too. Silver tarnishing, copper forming a green coating of an iron rusting, petroleum products combusting are all examples of chemical changes that are occurring around you. Although these reactions may be occurring at different rates and producing different products, they are still examples of chemical changes. In a chemical change, new materials are formed that are different from that starting material. So any type of metal that is going to rust or deteriorate. When the United States received the Statue of Liberty from France, it was completely made of copper, meaning it had this lustery shine on it like a brand new penny. And now you know that the Statue of Liberty is green because copper has this reactivity to water and moisture, and that's its form of rusting. Okay? Photosynthesis is the production of the food for plant cells. This is what causes them to be green. This is an example of what is being changed in that plant cell. In humans, we would equate that to digestion. When you and I eat food, our body has to break that down and turn it into different materials. So those are all examples of chemical changes. On the next page, new materials are formed. Ice melts, paper is cut, metal is hammered into sheets, and clay is molded into a vase. Seeing signs of these physical changes is easy. Something changes shape, size, form, or state. The only sure way to know whether a chemical change has occurred is if a new type of material is formed that is chemically different from the starting matter. A chemical change cannot be reversed easily. For example, when wood burns, you see it change into ash and gas that have properties that are different from the wood and oxygen that are burned. So the piece of wood becomes smoke and ashes. You can't put the ash and the gas back together to make wood. When the cake shown in figure 15 is baked, changes occur that make the cake batter become solid. The chemical change that occurs when baking powder mixes with water results in bubbles that make the cake rise. Raw egg in the batter undergoes changes that make the egg solid. These changes cannot be reversed. So here I've got a picture of all the different ingredients that might go into making a cake and then what the final result is. You could not start with a cake and try and separately pull these things apart and try and get back to what your original ingredients were. So a chemical change cannot be easily reversed. There's a new material that's being formed, and this example makes me hungry for a piece of cake. The science of chemical change. In these examples, you know that a chemical change occurred because you can see that a new substance is formed. It's not always easy to tell when the new substances are formed. There are other signs of chemical changes. One sign of a chemical change is the release or absorption of energy in the form of light, heat, or sound. The release of energy is obviously when something burns. Light and heat are given off. Sometimes an energy change is so small or slow that it's difficult to notice, like when something rusts. Another sign that indicates a chemical change is the formation of a gas or a solid that is not the result of the change of state. The best example I have for this is a firework. When the firework is lit and explodes, you've got this combustibility or this flammability that goes and interacts with the powder that's inside the firework. It makes a sound, a boom, it lights up, and it's hot, so it's giving off the heat, light, and sound. All three examples of something that's indicating a chemical change. This one's real obvious. Others might not be as obvious in the form of rust because it takes a long time for it actually to show that change. But when you see this, it might be the absorption of energy or the release of energy in one of these forms. Chemical and physical changes in nature. Often a color is evidence of chemical change, an example of which is shown in figure 16. Year-round, leaves contain yellow, red, and orange pigments that are masked or hidden by large amounts of green chlorophyll. In autumn, changes in temperature and rainfall amount cause trees to stop producing chlorophyll. When chlorophyll production stops, the masked pigment begin to become visible. So leaves changing color indicates a change in nature. This decomposition that's happening now that there's less sunlight out is an example of a chemical change that's happening inside the leaf. Physical weathering. Some physical changes occur quickly, others take place over a long time. Physical weathering is a physical change that is responsible for much of the shape of the Earth's surface. Examples are shown in figure 17. Examples also could be found in your own schoolyard. All of the soil that you see comes from physical weathering. Wind and water erode rocks, breaking them into small bits. Water fills cracks in rocks, and it freezes and thaws several times. The rock splits into smaller pieces. No matter how small the pieces of rocks are, they are made up of the same things that made up the bigger pieces of rock. The rock simply has undergone a physical change. Gravity, plants, animals, and the movement of land during earthquakes also causes physical change of Earth. So the weathering of Earth's surface is a physical change because those materials are still the same material. So when rocks break down, there's weathering and erosion. They're still the same material, they're just in a different form. Now the difference between that in chemical weathering is that there's actually a different material being formed. Chemical weathering. Cave formations like the one in figure 18 formed by chemical weathering. As drops of water drip through the rocks above this cavern room, minerals become dissolved in the water. These icicle shapes or stalactites are formed when the water evaporates, leaving the mineral deposits. There are instances of unnatural chemical weathering. For example, the acid in acid rain can chemically weather marble buildings, statues, and other outdoor objects. So chemical weathering can create different cave formations. And acid rain is a form of pollution that it gets into the water cycle when it rains down. It can cause these chemical changes because it's reacting with statues and buildings to erode those. Let's take a look at a couple examples and see if you can identify from the last two portions of physical and chemical changes which is which. Here's a picture of Holy Hill. This is just outside of Milwaukee that you can go visit, and it's a really popular place at this time of the year because all these leaves are changing color. That changing color of the leaves, that's an example of a chemical change within the biology of the leaves because the chlorophyll is becoming depleted and these other pigments are showing up to make this really beautiful color at this time of year. Weathering and erosion. This is a picture of Bryce Canyon. I picked this one because my younger brother's name is Bryce and he loves this place and wants to go visit it someday because it's a great example of weathering and erosion. This used to be relatively flat land because of the movement of water and wind over many, many years. It's created this canyon that's eroded and washed away these different rock formations. You can see that it's changed the landscape, but this is still the same rock and soil and sediment in this place. So this is an example of a physical change or physical weathering. Here's an example of chemical weathering. Again, it was described as the formation of stalactites. Those are the ones that hang from the ceiling, or stalagmites. Those are the ones that are on the ground, where you've got water and these mineral deposits. So things that are dissolved in the water become forming these stalactites, these pieces of rock that are hanging down, because there's actually a change in the chemical composition that's happening. Another example of that is the example of acid rain. This is a chemical change. Here you see the original statue, and after years and years and years of rain and the acid eroding away at the material that was used to make the statue, the change that's happening in that composition. You can't reverse this. You can't go back and fix it because it's a chemical change. Your assignment is to make sure you've completed your notes for this section and take on the reinforcement. God's blessings.